Look at how most decentralized applications operate today. Everything stops at the interface. A smart contract executes, but only after a user reads a prompt, hesitates, and physically clicks approve. That delay, the biological pause between intention and cryptographic settlement, is a source of economic leakage. Every millisecond a system waits for a human, capital efficiency drops. Machine-to-machine APIs bypass the interface entirely, executing thousands of decisions instantly. Because of this gap in speed, the most valuable infrastructure being built right now remains invisible. It runs in the background, removed from the user interface. Blockchains are transitioning from passive storage ledgers into active, verifiable state machines, driving autonomous behavior. When capital moves at API speed, any workflow tethered to a human approval loop becomes a permanent source of friction. In a machine-native environment, these human-centric systems function as legacy constructs. This operational shift leads to a specific operational concept, the zero-human company. This is an enterprise where executive strategy, software engineering, and quality assurance are entirely replaced by code. Operating at this level requires a structured, hierarchical workforce of specialized AI agents. But getting multiple models to operate an enterprise hits two immediate engineering bottlenecks. First, AI models suffer from severe cognitive degradation over time. Second, relying on human-gated settlement layers slows down any financial action they decide to take. The Denarii DFi Paperclip Orchestrator was designed specifically to solve these exact problems. We are going to break down the first principles of this architecture, moving from a single AI prompt all the way up to a fully autonomous cross-chain corporate entity. Standard LLM APIs are entirely stateless, suffering from the memento man paradox. Waking up for the next call, the agent has zero memory of its goals. The orchestrator fixes this with a heartbeat check-in system. This recurring loop programmatically forces the agent to read its designated persona, current assignments, and definition of success before it executes any new action. The second mechanism prevents the agent's context window from diluting. It is a file-based architecture called the para-memory system. Instead of holding everything in active memory, agents read from and write directly to this directory. This allows the system to persist critical strategic files and complex codebases across multiple sessions without ever bloating the active token count. By combining the heartbeat loop with para-memory, systems architects transform a stateless conversational model into a continuously stateful digital employee. However, there is a professional misconception that a company can be automated simply by chaining these AI outputs together in a sequence. Doing so ignores the measurement gap. This is an economic danger zone, where the cost to automate a cognitive task plummets below the cost to manually verify that task. This gap incentivizes operators to deploy unverified systems at scale, which inevitably leads to catastrophic, compounding operational failures. This graph shows the compounding errors in an unverified AI sequence. Assume a single step has 95% accuracy. Across 10 steps, that accuracy degrades, dropping to exactly 59.8%. To stop this degradation, the architecture requires an independent quality assurance agent. Its sole purpose is auditing output at intermediate checkpoints, effectively resetting the error probability back to baseline. Implementing this specific multi-agent check and balance pattern drops the end-to-end failure rate from roughly 40% down to just 0.25%. Engineering strict adversarial verification topologies between multiple models is the primary requirement for autonomous scale. Once agents possess stateful memory and mathematical reliability, they must be organized into an execution hierarchy governed by an orchestrator. The Paperclip AI Orchestrator replaces traditional software suites by breaking high-level corporate intent into distinct pillars of automation. For major strategic decisions, the orchestrator uses a Byzantine fault-tolerant consensus engine. Instead of a single point of failure, the system forces specialized personas, like a corporate CEO, a risk quant, and an engineer, to debate using structured JSON prompts until they reach a mathematically validated consensus. This allows these agents to handle massive autonomous workloads, like continuously auditing new smart contracts for reentrancy bugs without hiring external human security consultants. The orchestrator functions as a machine-native operating system. It translates plain text strategic intent directly into executable corporate operations.
But this creates a final bottleneck. If AI agents make strategic and financial decisions in milliseconds, they cannot rely on traditional banking rails or slow, congested blockchains to settle those transactions. This table outlines a specialized settlement abstraction layer. Denarii DeFi utilizes the trinity of DLT, mapping operations across 3 distinct ledger networks to optimize for speed, finality, and logging. The XRP Ledger is utilized specifically for sub-second value transfer and decentralized exchange routing. Algorand provides pure mathematical block finality, ensuring machines never guess if a transaction cleared. Finally, Hedera is layered on top to provide high-throughput, predictable fee audit trails for every agentic decision. To protect this infrastructure from Sybil attacks and align network incentives, the orchestrator is hidden behind a strict cryptographic token gate. Only wallets that are mathematically verified to hold a specific threshold of the native DeFi token supply can access the underlying infrastructure. By pairing multi-chain settlement rails with strict on-chain access requirements, the architecture removes human delay while maintaining absolute permissioned security. When you stack these components together, you see the actual engine of the agentic economy. The multi-DLT settlement rails on the bottom, stateful memory and verified QA nodes in the middle, and the orchestrator governing from the top. This forms the vault, a secure cryptographic core where multi-chain digital assets are managed and settled entirely by machine logic. The transition moves the internet toward programmatic organizations that replace manual labor loops. Economic value in the next cycle of the internet will relentlessly concentrate into invisible protocols that reduce execution friction. These principles, multi-agent QA validation, stateful memory, and API speed settlement, are the core blueprints for the post-interface web.